Namaste. Welcome to the Indian Knowledge Systems Primer Course for Children. In this session, we will look at the Katapayadi number system. In the Indian knowledge traditions, texts have been authored in the form of beautiful poetic verses and short sentences called sutras. Since the teachings were all orally transmitted, the acharyas had to be experts in composing poems, so that the principles and the concepts can be easily memorized by the children. That makes us wonder, how would a math acharya be able to compose every concept as a poem? Even if they could explain the concept, how could they represent numbers in poetry? To solve this, the Indian mathematicians came up with unique number representation systems. One such system is the Katapayadi number system. Now, before going into the Katapayadi number system, let us look at the Sanskrit alphabets. The Sanskrit alphabets comprise of Swara and Vyanjana. Swara or the vowels are A, I, U, U, R, L, A, I, O and Au. The Vyanjana or the consonants are G, Kh, G, Gh, Ng, Ch, Ch, J, Jh, Nya, Ta, Tha, Da, Dha, Na, Ta, Tha, Da, Dha, Na, Pa, Pha, Ba, Bha, Ma, Ya, Ra, La, Va, Sh, Sh, Sa, Ha. These 33 or the consonants are Vyanjana. Also, the consonants combine with all vowels to produce various forms. For example, Ik plus A will give Ka. Ik plus U will give Ku. Ik plus I will give Kai. Also, in Sanskrit, we have the concept of conjunct consonants. That is, a consonant which is attached to a vowel is preceded by a consonant which is not attached to a vowel. Here, if we see, Ik plus Ta will give Kta. Ta is the consonant that is attached to a vowel. It is preceded by a consonant which is not attached to a vowel. Ik plus Ta will give Ta. Then Ik plus Sha will give Ksha. It plus Ra will give Tra. Ij plus Nga will give Nya. Now we move on to Katapayadi number system. The name Katapayadi stems from the fact that here the Sanskrit alphabets Ka, Ta, Pa, Ya, etc. are used to denote the numbers. So the rules of Katapayadi number system are as follows. In this system, the vowels standing alone represent the value 0. The same vowels, when in conjunction with the consonants, will not have any numerical significance, which means we are going to ignore that. The consonants K, Kh, G, Gh, etc. will have numerical values. So this table gives the numerical value for each letter in Katapayadi number system. As the name says, we have given the value 1 for the letters K, T, P, Y. Now, the succeeding letters will have increasing number of values. So, K will have the value 2, G will have 3. Now, Ch will have 6. Now, when we write it like this, after Jha, we have Nya. This will have value 0. Note that here after 9, the value is 0. Then we have Ta, for which we have already given the value 1. So, Tha will have 2. So, this goes on, and then the letter Na will have value 0. Pa will have 1. The same way here Ma will have the value 5. The letter after ma is ya, for which the value is already 1. Then ra will have 2, la will have 3, va will have 4. The next letter is sha, for which the value is 5. Sh, sa, ha. For ha, the value is 8. As we previously saw, the standalone vowels will have the value 0. These rules are given in a beautiful verse by Shankaravarman in a text called Sadratna Mala. The verse goes like this. Nanya vachascha shunyani sankhya katapayadayaha mishre tu pantyahal sankhya nacha chintyo halaswaraha. The meaning of this verse is na, nya and ach. Ach is the technical name that is used for vowels or the swaras. So, na, nya and the vowels will have the value shunya, that is 0. And sankhyaha katapayadayaha. So, ka, ta, pa, ya and the other consonants will have numerical values, that is starting from 1. Then mishre. Mishre is, in the case of conjunct consonants, we take the upantya hal. That is, hal is the technical word that is used for consonants. So, we just take the last consonant. Nacha chintyo halaswaraha. So, the consonant that is not joined to a vowel should be disregarded. As we go through examples, this concept will become clear. Now, we have the letter gu. Gu is made of ig plus u. Now, we have seen that the vowels only when stand alone take the numerical value 0. Here, it has combined with the consonant. So, we can ignore this vowel. We only take the consonant g. If you recollect the table, the values go ka has 1, then kha has the value 2, ga has the value 3. Here the value will be 3. We have this rule ankanam vamato gatihi, which means that while decoding a numerically encoded word, one should read it in the reverse order. Let's see how. Now, let us see few examples. We have the word here, chataka. Chataka means a sparrow. Now, we'll start giving the numerical values by looking at the table. We have the first letter cha. The letter here, cha, has the value 6. Let's write 6. Ta has the value 1. Ka has the value 1. The rule that we saw was ankanam vamato gatihi, and we have to write it in the reverse order. So, what will be the value for chataka? It will be 1, 1, 6. Then, the second word is amba. Amba means mother. This is a standalone vowel, right? So, when the vowels stand alone, then the value will be 0. So, we will write 0. And then, here we have im, that is a consonant which is not combined with any vowel. So, we can easily ignore this. Then, we will go to ba. We just see the value for ba. Where is ba here? We have ba. The value will be 3. Now, we write 3. Should we leave it here? No. We have to follow the rule ankanam vamato gatihi. So, we are going to reverse it. The value will be 30. The third example is vikramaha. So, va will have the value 4. So, we write 4 here. And kra. This kra is a conjunct consonant. This is made of ik plus ra. Now, what did we see? In case of a conjunct consonant, we are only going to take the value of the last consonant. So, we are going to ignore this and then take the value for R. R has the value 2. So, we write 2. Ma. Ma has the value 5. So, we write 5. By the rule Ankanam Vamato Gatihi, the value of Vikramaha is 524. Here are some examples for you to try on your own. Kataha, Kakaha, Shastram, Kamalam, Mahatma, Nayanam. You can look at the table and try to decode these words. These are the solutions for the given words. So, in the beginning of the video, we saw that the Katapayadi number system was used by the Acharyas in the poetic verses to represent the concepts and the numbers, right? So, how did they use it? Now, let us see one of the application of the Katapayadi number system. So, there was a great poet called Melpattur Narayana Bhattadri. He wrote a beautiful devotional poem called Narayaniyam. There, he closes this devotional poem with the verse Ayurarogya Saukhyam. On one hand, it is the benediction of longevity. Ayu means life. So, Ayu, Arogya. Arogya means health. And Saukhya is happiness. So, he asks the Lord for longevity, health and happiness. But on the other hand, it is a chronogram. How? What does it represent? Let's see. Now, let's take this word Ayurarogya Saukhyam. So, it is a compound word. Compound word of Ayuhu plus Arogya plus Saukhyam has become Ayurarogya Saukhyam. Let's try to decode this using the Katapayadi number system. Now, we have written the letters here. So, the first letter is A. It is a standalone vowel, right? So, we give the value 0. Then, we have Ya. We know Ka, Ta, Pa, Ya will carry the number 1. So, Ya will have the value 1. Then, after Ya, it's Ya, Ra, right? So, the value will be 2. Ro will also have the value 2. Gya, it is made of 2 letters here. If we see, it has Ig plus Ya. Ig does not combine with any vowel, so we are going to ignore here. So, we give value only for the letter Ya. Then we have Sau. The value for Sa is 7. Then we have Khyam, where it is made of Ik plus Ya plus Im. Here, both Ik plus Im are consonants which has not combined with any vowel. So, we will ignore it. We give value only for the letter Ya. So, we have got 0, 1, 2, 2, 1, 7, 1. By following the rule Ankanam Vamato Gatihi, the value for the word Ayurarogya Saukhyam will become 17122110. What does this number represent? Let's see. This chronogram indicates the date of the completion of the work. So, 17,12,200 civil days from the beginning of the present Kali Yuga has passed, which would equate to 8th December 1586 CE. In another example, we see that there is a significant text in astronomy called Tantra Sangraha. In that, Nilakanta Somayaji gives 2 phrases. He Vishno Nihitam Kritsnam, Lakshmisha Nihita Dhyanaihi. The first quarter of the first verse is He Vishno Nihitam Kritsnam, which means, O Vishnu, everything is embodied in you. But it is also a chronogram for the date of commencement of the work, which is 1680548, which corresponds to the date March 22, 1500 CE. Now, the third quarter of the last verse of this work is Lakshmisha Nihita Dhyanaihi. This gives the date of completion of the work, which is 1680553, which corresponds to the date March 27th, 1500 CE. Hence, we see that the author Nilakanta Somayaji has brilliantly used this Katapayadi number system to indicate the date of commencement of the work in the first verse and the date of completion of the work in the last verse. And we see that he has just completed this brilliant work in a matter of 5 days. Now, let us see another example for the Katapayadi number system. Katapayadi number system is not just used in the beautiful poetic verses, but then it is also used to decode the swaras of the Melakarta ragas. There are 72 Melakarta ragas in the Carnatic music system. Now, just by knowing the name of the raga, we will be able to decode the swaras of that particular raga. First, we should know that all the 72 Melakarta ragas will have the 7 swaras in them. All the 7 swaras will be there. We have Sa, Ri, Ga, Ma, Pa, Dha, Ni, and then this Sa is the higher note. Now, in all the 72 ragas, the position of Sa, Pa and the higher note Sa will be the same, whereas the Ri, Ga, Ma, Dha, Ni will have variations. Now, to decode the swaras, let us see the steps. From the first 2 syllables of the Melakarta raga, we can decode the swaras for that particular raga. Now, if the Katapayadi number of the first 2 syllables is less than 36, then the Ma position will be 1. So, it will have Ma 1. If it is greater than 36, then it will have Ma 2. Now that we know whether the raga will have Ma 1 or Ma 2, we move on to the next step. If the Melakarta number is greater than 36, subtract 36 from that Melakarta number. Step 3. Now, subtract 1 from the revised Melakarta number. Let this be n. Now, divide n by 6 and note down the quotient and the remainder. Depending upon the quotient, we will now determine the positions of Ri and Ga. Remember, n will always be less than 36 because we have already reduced it by 36 in the previous step. Depending on the value of the quotient, we can now determine the positions of Ri and Ga. Note that the value of n will be less than 36. So, when you divide the number which is less than 36 by 6, the quotient can only be from 0 to 5. Here is the map for the quotients from 0 to 5 to determine the positions of Ri and Ga. Similarly, with the value of the remainder, we can determine the positions of Dha and Ni of the raga. Now, if we divide any number by 6, the remainder is only going to be from 0 to 5. Now, here is the map for it. Now, let us try to understand this through an example. We take the raga Dhira Shankara Bharanam. Now, the first 2 syllables of this raga is Dhira. So, the value for Dha is 9 and Ra is 2. By the rule Ankanam Vamato Gatihi, we reverse this. So, the obtained Melakarta number is 29. Now, 29 is less than 36. What did we see? If the Melakarta number is less than 36, the position of Ma will be 1. So, we have Ma 1 here. Now, the next step is to reduce the Melakarta number by 1. So, the number is 29. So, we reduce it by 1. So, the number is 28. We now divide this by 6. 6 4s are 24. We get 4. So, this is the remainder and this is the quotient. So, if we see If the remainder is 4, then we have dha 2 and ni 3. If the quotient is 4, we have re 2 and ga 3. We'll check. This has re 2 and ga 3 and dha 2 and ni 3. So, this satisfies. We'll see another example here. We take the raga Senavati. So, the first two syllables are Sena. The value for sa is 7. The value for na is 0. Now, when we reverse this, we get the value 7. Senavati is the 7th Melakarta raga. So, if we follow the same steps, now we see that 7 is less than 36, right? So, we have ma 1. We then reduce 7 by 1. So, we get 6. We divide this by 6. So, the quotient is 1, then remainder is 0. So, we have re 1 and ga 2 and dha 1 and ni 1. Now, let us look at this raga Dhatuvardhini. So, the first two syllables are dha and tu. So, if we apply the Katapayadi number system, the Melakarta number that we get is 69. So, now 69 is greater than 36, right? So, hence we have ma 2 here. Now, what should we do? We should first subtract 36 from 69. So, what will we get? We will get 33. Now, reduce this by 1. We have 32. We divide this by 6. We get quotient as 5 and remainder as 2. Now, again, with the value of the quotient and the remainder, you can easily get the raga scale. Isn't this brilliant? So, just by knowing the name of the raga, you can tell the raga scale. This image captures all the combinations of the 72 Melakarta ragas. If we apply Katapayadi number system, we will be able to deduce the scale for most of the ragas present here. In this video, we have seen an introduction to the Katapayadi number system. We have seen its rules and also some applications of it. Do try out this number system to get a better hang of it. Thank you. Dhanyavada.